Swayam Prabha. Digital India. Educated India.
A very warm welcome in the 5th module of week 5 of the course Roadmap for Patent Creation, titled Indicators for Patentability. When we think of patentability, we immediately think about the 3 criteria: novelty, non-obviousness and industrial applicability. And now means out of this 3, that industrial applicability and novelty check are very clear without much gray area to identify or to take the decision on it. So, anybody can easily identify novelty and industrial applicability. However, with respect to non-obviousness, some indicators are necessary. We can say to that these indicators as indicators of inventive step also. So, if there is any such guidelines present or there are some listed indicators to judge this, yes, there are some guidelines. So, let us check what are that indicators for the inventive step. These indicators are: first, distance; second, surprising effect; third is long felt need; fourth, failure of others; fifth, complexity of work; sixth, commercial success; seventh, cheaper and more economic product; and simplicity of the proposed technological solution; and the eighth, that is a prior art motivation. So, we will now check one by one what these 8 things or indicators are. So, we will start with the distance. It is to be decided as to how much is the distance between the subject matter of the invention and the prior art. So, this is a distance between the what is the subject matter that is under consideration now and what is a prior art. If such distance is large, it is the better and it is easy to establish the inventive step. So, let us check the example. Subject matter of an invention and a prior art. We are now well aware about the prior art. So, how to judge based on this criterion, that is a distance. So, if say you are working in a chemical engineering domain or you are working in a chemistry realm and you have invented some composition. So, subject matter of the invention is say X composition, and this composition, suppose it is useful to heal the wound. So, if any wound is there, that can be healed, cured by this combination. Now, there are so many such compositions available in the state of the art. How now you will able to judge this, that is a distance thing, or how you will use this distance as a indicator to judge whether your this invention is a patentable or not. So, all the available composition, that is a prior art, and the subject matter under consideration, that is a composition X, we have to compare it for the indicator, that is a distance. So, you have to justify this, how your subject matter is, anybody should consider for grant of a patent by comparing the 2 sets and providing how much distance is there between these 2 sets. Which are the 2 sets? That is the subject matter and the state of the art. So, there may be 1 to 10 different kinds of wound healing composition and yours is having that X composition. So, you have to compare that X composition with each and every the available whatever the wound healing cream or wound healing composition is available, and you have to provide the data to substantiate whatever you are claiming. Okay. So, you will decide also you can also decide some parameters like say what is the method for preparation, what is the method for application, then how many days it take to give you the result, that is how much time that particular composition take the heal or cure the wound, and so on. So, you can consider or decide on the parameters and you can give the comparison of this 10 if 10 such compositions are available in the market. So, thus inventor have to substantiate creation of new composition by the data, and of course, that data should work, means that whatever you have claimed by giving the data it should work, it is a patent. So, product should work, no one can give for the sake of patent application that particular data, whatever data you are giving or claiming through that data you are putting it into the description part, then it should work. So, and you should remember that patent system is very robust along with a thorough examination. We have seen how thoroughly the examiner do the examination of the patent. So, that thorough examination by the examiner, and along with that there is a pre and post grat opposition. So, it is a very powerful system and you have to substantiate everything, whatever every claim is there with a proof, and your product should work. So, when we are talking about the distance, that distance suppose you are substantiating by using the data, then that data if somebody works on that, the same result should be received after doing that particular experiment. So, I hope you have understood this indicator, that is a distance. You can apply the same, suppose you are working in a medicine field, then you can apply it to the diagnostic tool. If you are a mechanical engineer, you can apply it to the machine. If you are a civil engineer, you can apply it to the effective construction. So, if you have devised or if you are proposing effective construction method, then you can apply all this and then you can substantiate your claim by giving this data. Okay. Now, the next one. The next one is the surprising effect. So, if invention is giving any surprising or unexpected effect, then yes, this can be considered. So, what is the meaning of this? So, let us take one case. We know how the penicillin is discovered, right? It is the contribution by scientist Alexander Fleming, and it is a chance discovery. We know that what is the chance discovery is that in 1928, when Alexander Fleming was working in the St. Mary Hospital in London, he has discovered the penicillin. Now, Alexander Fleming, he has not filed the patent. He just discovered that thing penicillin in 1928. So, that story probably you might be knowing, that he has kept the plates in the drawer, and next day when he visited the lab, what he found that the bacterial culture was not grown there, and then he started why that bacterial culture is not grown, and then he found that okay, something is there that is not allowing the bacteria to grow, because he has done the experiment and the same result is found. And then what happened, that at that time also that importance is not realized, but when World War II is started, at that time this penicillin, this crude penicillin is used for the curing the wound of the soldiers, and it is found that just application of that culture which is grown in the plate, if you apply that thing, it is curing that injury of the soldiers. And then further it is the further research is done, and then in the Oxford University, and then it is patented in 1948. That was the story of the penicillin. So, what was that? Why that time is there, that time gap is there from 1928 to 1948. This effect was surprising effect, it was not expected, it was like a chance discovery. But Oxford University has to spend the time on extraction of penicillin, it is in a very crude form, then it has to clear the solution was little bit not clear, it was some what we can say that the solution which is received directly from that penicillin culture, it was not clear, which can be applied to the which can be considered as a medicine, then that purity also, all that processes has taken place. The crude form of penicillin is then converted into pure form, but that whole time has been taken by all these processes, and US pharmaceutical company supported the production, the scaling up for that production is done, and inventor Andrew Moyer, he filed the patent for this. Okay. So, this is similar on this basis, just now we have seen the penicillin example, discovered, it is a surprising effect, and then it has been patented in 1948 by the another what we can say inventor, that is Andrew Moyer, although it is discovered by the Alexander Fleming. So, this is one example how that surprising effects you can use as an indicator for the what we can say the filing the patent. The other example we have already seen the restriction endonuclease, but it is like a very what we can say, it is a decided experiment, and where Cohen and Boyer were working, and what the interesting thing is that enzyme, they have discovered this restriction endonuclease enzyme, which is acting as a seizure, a very precise cut in the DNA to get that particular what we can say piece of a gene. It is a very interesting discovery. So, you can also consider this is a very surprising effect using a enzyme to cut the DNA, everything is invisible, and it works well to cut that particular piece of DNA in a very precise way, right. So, you can just visit the case we have already dealt in the week 1, that Genentech case. Okay. Now, another example I can give, if someone develop a method of cleaning sewage in just 2 hours, we are just facing such a problem of waste disposal, and if somebody comes up with some invention like a cleaning of a sewage, that will be definitely something very surprise effect, 2 hours only, and your sewage whatever it is taking time for the waste disposal is very headache for so many people, it will be solved in just 2 hours. So, if such kind of thing comes, obviously you can consider this for the patentability. Okay. So, this is about the surprising effect. Now, the next is a third indicator, that is a long felt need. So, if the claim solves a long felt need, there is a presumption that a claim is not obvious, as other inventors might have also tried. Say some problem is there, so many people or so many scientists, so many individuals are working on it, right, on the same problem, but it is not solved for years, say 5 years, 7 years, everybody is working, but it is not solved. But somebody, if that solves that thing, that long felt need is there and that need is fulfilled, then in that case we can say that okay, this is, yeah, you can consider this for the patent. We can take the example of an invention of an electric light bulb. Who invented that? Everybody will say Edison. Actually, it is not. Invention is by Davy and Swan, Joseph Swan and Humphrey Davy. But if you see, the patent is filed by Edison, and we will just see how that happened. Now, again one more example I will just put forward. Think of a Ford. Who invented Ford invented that automobile. Is it true? Just think over that whether Ford invented the automobile. Just think over that thing. I will not give the answer here. We will now concentrate on the electric light bulb. So, everybody, that historians agree that Thomas Edison was not the inventor of the electric bulb, but he made it commercial viable, right. So, earlier light bulbs were experimented with as far as in 1802, and at a time, means after that almost 23 others have tried, that they have invented, they have invested their time on this light bulb. Some of them were still working on that thing when Edison was also working. Now, what happened when Swan has invented that thing? He used carbonized paper filament, but the poor quality of the vacuum in the bulb caused the carbon to disintegrate rapidly. So, the bulb glowed for just 13.5 hours. What Edison has done, that same whatever Swan has invented, what he has done, he used better vacuum pump, and after he and his what we can say the lab colleagues, they have tasted thousands of material. He has put lot of effort on that thing. Obviously, he has spent time to check which material will be suitable, so that wire, whatever that filament is there, right, how that will be a durable one, because when Swan has used it, it is for just 13.5 hours. Now, what he discovered, means Edison and his colleagues, his lab mates, what they have done, that they have derived that filament from bamboo, and from bamboo they realized that okay, 12 hours it is lasted, 1200 hours it is lasted, from that 13 and a half it is 1200 hours. And today when we see this bulb in which the filament is made of tungsten, it lasts about the 1500 hours. So, we can say that there are three factors which contributed in the Edison's success: a durable incandescent material, elimination of air from the bulb, a better vacuum system whatever he has used to eliminate that air, and the filament material whatever used was of a high resistance. These were the three things, and he has done experiment. Although Swan has invented that thing, Edison has put his efforts to make it commercially viable. He has put his efforts to make it available, that understanding which filament will be useful to give that particular result. So, Thomas Edison have put effort and he has filed the patent, but what next happened after that? Swan sued Edison for this patent, and then what happened is that the title of that patent was a carbon filament or a strip coiled and connected to platina contact pads. That was the title of that patent which is filed by the Edison. The long felt need was there, and it is solved by obviously by Joseph Swan first, and then the material, that is a filament whatever was there, that was given by Edison. That is, from that we can say that a prototype is given by Joseph Swan, and it has taken up to the further development by the Edison, that is up to commercialization. So, this thing happened, but if you see the case whatever happened, that Swan sued Edison for that patent infringement, and the British courts ruled against Edison, right. So, that what was the punishment given to Edison is that as a punishment Edison has to make Swan as a partner in this electric company. That was the case, that was the what we can say the result, or the result of that patent infringement done by Edison. Okay. So, what US Patent Office done, that what was the interpretation or what is the decision given by US Patent Office? They decided in 1883 that Edison's patent was invalid, as it also duplicated the work of another inventor. We have already mentioned the name of the inventor. So, there were two inventors who have done that thing. Edison has worked on it, and then he has developed that, he worked on that filament, and it has he has taken it from prototype to the commercialization. But that was a long felt need, and that was solved by these scientists, right. So, when such kind of thing is there, definitely that long felt need, if it is a solve, this will be considered for the grant of the patent. Okay. So, if the inventor solves a long standing problem by using in this way, whatever the conventional way, the materials or techniques that are recently become available, then this is not inventive. So, we have seen how the case of Edison. Now, the few more points I am adding, that what can be considered when we are considering the long felt need. So, if that long standing problem is there, and some new methods are, as technology is developing, the new techniques are coming, and if with the same techniques which are now available that problem is solved, then this is not an invention. So, although the long felt need is there, but it is an obvious thing that you have used the techniques which are made available by the technology, then that cannot be considered for the invention. I repeat this thing. We have seen the example of that Edison case we have seen. Now, we are seeing the few more things related to long felt need. Okay. So, here I have given you the example that if somebody, the long felt need is there, somebody what he has done, the new techniques came because of technology is developing. Now, only simply he has used that technique to solve that particular problem. If such kind of thing is done, it is not considered as a invention, because it is obvious that any person who is skilled in art can do that thing, or he can think in that way. So, this will not be considered. Now, the second case may also happen, that as time goes, there may be some economic circumstances will be there. So, economic circumstances may be in such a way that the material which is used for that particular machine, there is some development, and because of that, if some new material is invented by somebody else and you found that okay, that material if it is used here, the machine, the cost of the machine will be reduced. So, cost effectiveness is there, or material is becoming cheaper, and because of that what we can say, the value of that product increases. But what is the reason behind it? It is just the economic circumstances. There is no any contribution by the inventor as such, and any person who is skilled in the art can anticipate this thing. Then in such case it cannot be considered as a invention. So, the first we have said that as time goes, technology is developing, new techniques are coming, and the inventor applies that thing and he claims that he has developed something, then it is not, because person who is skilled in the art can apply that thing. Similarly, the economic circumstances came, and then because of that, that material become what we can say cheaply available. It is like the cost effectiveness is observed. Then there is no any contribution of an inventor. It is just a economic circumstance, and anybody who is working in that area can think of that thing. Then it is not the, obviously as it is, we will apply the Fosita, and then obviously it will not the invention. Okay, then suppose someone solves a newly arisen problem by the use of available resources in an obvious way. We have already concentrated on that. Problem is new, it is not a long felt need or something, just it is arised, but used a obvious way by the available resources. Again we will not consider this for the patent, because obvious way is used. Okay. So, there is no inventive step unless the inventor has been the first to identify the problem. Okay. So, no patent as obvious solution is given to the problem. So, third thing we have cited that in such case you can't consider this for the patent. So, change in technology, economic circumstances, and now the new problem, but a obvious solution, no. We will see example. So, a claim to a polypeptide comprising a antigenic determinant of the hepatitis C virus was found that to be non-obviousness, because despite the attempt, sometimes what happens, we have seen the example that Edison, he has received the grant for the patent. We have to appreciate the efforts, means what is the contribution of Edison there? So many other inventors were trying, 23 other inventors were trying, and he is the successful person. His lab is a successful. He was able to give you the filament, the material which is a durable. So, that point, that whatever point is there, he can claim on that, but the original invention of a bulb is by the Swan, right? We have to remember that thing. And then already I have given you the case that both were then partners in the electric company. Now, here the long felt need is there in this example also. I give you, I just repeat that thing, a polypeptide comprising an antigenic determinant of the hepatitis C virus. It was found to be non-obvious because despite the attempts of numerous research groups, so many people were working on it over 10 years to identify the agent responsible for the non-A, non-B hepatitis, which is later named as a hepatitis C. The patentee succeeded in a unique fashion way by adopting a known technique. The technique was known, but it was adapted and he solved the problem. Then yes, he is a successful, because 10 years everybody is struggling to solve that problem, but this inventor solved that, and yes, here the contribution of the inventor should be appreciated, and that will be considered for the patent. So, it is important to have an evidence of a long felt want or unsuccessful attempts of other research groups, any evidence as a novelty, years of delay in developing the prior art, and the advantage of stemming from the invention. So, these things are very, very important. So, now next we know if anything which is obvious to try, then it cannot be considered. Obviously, we have said that thing. So, how to judge this thing? So, for example, if a skilled worker in a particular field could be expected to know of a use of material to achieve a certain result in that field, then an invention cannot be considered as a long felt need solved. A worker who is continuously working in that manufacturing unit, he also can guess Rather these people who are continuously working on the product, they give a very good solutions because every day they are handling that particular process. So many times whenever we think of IP management, we always give importance to the shop floor people, because we have to tap the ideas which this shop floor people are giving you. So company should have some mechanisms to tap that ideas, because these people are working on the same thing for years together. So they will give you the better solution for what we can say, the maybe to replace the particular thing or to make the process more efficient. So we have to explore that thing. So okay, I just digress it from the main topic, but just to put you the importance of this. So here what the thing is happened, that a skilled worker that in the particular field, he can just give you the material which you can use. So if that kind of thing is there, obviously it is an obvious thing. Again I can reiterate the Fosita thing, and then we will not consider that thing, though it is a long felt need. Okay. Sometimes that use of same material results in a substantial result. Yes, if that substantial result came, then we are considering for the consider it for the patent grant. In such case, it may be considered for a grant as the result was not anticipated, it was totally different. So thing which looks obvious and result expected also anticipated, however in actual something new comes out, right, the output is something different, then yes, in that case if the results is substantially different, it is very useful following other criteria and guidelines, then in such case use of that material can be considered for the grant of a patent. So if subject matter provides development on reducing side effects or increased efficacy, then inventions where you can consider for the grant of patent. Okay. So here what important thing is there, that the processes are there already, material is already there, the result is anticipated. Okay, this will be the result if that particular process is followed, but nobody have done that thing, and then after some 5 years the same process is going on and somebody tries that method by using that particular material and all that thing, and instead of getting that a normal whatever anticipated result, some different result is coming. You got the thing, what explanation is there, whatever earlier we have discussed, that here the effect is different, although it is anticipated in one way, anticipation was like a product A, but actually it is a B and it is like a substantial effect, all other criteria of patent are satisfied, and then obviously you can consider this for the patent. So this is for the long felt need. Now the next is the failures of the other. If other inventors have tried to solve a problem and were not successful, the claim will likely involve an inventive step. For example, we have just seen the example of Edison. Everybody tried on that thing, right? 23 other groups were working on that thing, but Edison was successful. So that effort of Edison to claim for that particular invention of that filament, definitely that is his contribution. Again I repeat, invention of filament is his contribution, but a light bulb, it is a contribution of Joseph Swan. Okay. So if somebody says who invented the bulb, then Swan is the answer. Who has given that filament? Edison has what we can say, by so many experiments, so many thousands of material here that lab has tested, and then they have given this filament, right. So we have to consider it in this. So others who were working, so for example I will give you another example. Suppose somebody is working in a agricultural domain, and the method of what we can say, the method where the cover of or the husk, whatever we call, if that there is some methods which are used to remove that husk of that say rice, there are already the machines available. But the thing is that if it is not giving you the result, say it is not so effective, or it is not giving you the result in a short time, or if you are doing that thing, the wastage is more, that is breaking off that that whatever grain is there, it is the percentage is large, if that kind of thing is happening, right. And now the need is that everybody is trying to give the machine that okay, it is very quick, very easy, loss is almost 0, that is wastage is very, what we can say, 0. After once you put that what we can say the output from the field, immediately you are getting the separated product as that cover, that is that grain husk part is separate, and the proper that grain part, that inside grain part is separate. If somebody gives that thing, already some say 5 years people are working on that, but nobody is able to give you the solution. But here somebody comes up with the solution, then obviously that machine can be considered for the patent. Okay. So, the failures of others, but that one inventor who is working on it say 5 years and he has given the machine, then definitely that will be considered as a, what we can say, the consider it for the grant of a patent. He has to prove that thing, that okay, in the background he should give that okay, so many people have worked that thing, now we have given this solution and now it is giving you the perfect result without any loss, and then that way he can claim the invention. Now, the next, complexity of work. So, what is the meaning of that? If the work undertaken by the inventor in order to produce the invention was very complex, right. So many biological processes, so many biotech processes, they are so complex, because the first thing is that you are not able to see that things by your naked eyes. You have to work under the microscope and you have to produce that, you have to give the result. So, if such kind of complexity is there, I always remember the example of a restriction endonuclease. Such a that enzyme which is cutting the, which will able to cut the DNA in a precise way, then that is very complex thing, right. And then again joining at that particular time, very complex process. So, if that kind of complexity is there and it is not readily carried out, that is the indication that it was not a matter of routine. In such cases, the invention is a non-obvious, right, because that complexity, whatever the complexity is, that complexity is a solved. Okay. Now, moving further, the next is a commercial success. Commercial success, it is considered as an inventive step, but it is not conclusive, right. So, when something is produced, prototype is ready, the inventor has developed that particular prototype, but he was not able to commercialize it, right. Commercialization, that from prototype to actual product, this is a very, in the management we call it as a death valley, right. Why? Because this process, that from prototype to that actual commercializable, that ready to market kind of product, it is a very challenging step, right. And you know that because of that only so many startup related that activities are there, that supports that from prototype it should come to the market. So, this commercial success, whatever is there, it is considered as an indicative, because you have to put lot of efforts to make the prototype as a product ready to market, right. But it is not conclusive, because all other guidelines related to patent, right, that has to be followed. So, and therefore, you know that the technology transfer related technology transfer is a challenge, because so, and you will not see, means because of that only we see that okay, so many patents are filed by, I will take directly the names of CSIR, or we will take a example, patents are filed by IIT. But there are so many other reasons, but one of the reason is that commercialization from prototype to that actual ready to product is a very challenging task. It is like a, already in the management term we say, when we say IP management thing, we say it is a death valley, and that technology transfer process is a very challenging, and so there are so many efforts are there, and therefore, that commercial success we can consider as a indicative for a inventive step, but remember it is not a conclusive. Okay. So, this is the commercial success. The next is like a cheaper and a more economic product and a simplicity of a proposed technological solution. You can easily understand this thing. So, the product X product is already in the market, but the what we can say, it is made more economic. So, suppose it is costing 100 rupees, now it is costing just 10 rupees, perfect. you can consider this for the filing patent. Simplicity of the proposed technology. So, there was a washing machine which was very tedious to work on it. The two compartments are there, we have to remove the clothes from that one compartment to other compartment for drying and all that thing. And then later now you see the very fantastic automatic washing machine. So, the thing is made very simple, so that the same that machine is there, washing machine is there, but if you see that history of that washing machine, then you can see that it was like first it was like when you want to dry that cloth, you have to put the cloth in the it's like a sugarcane, if you have observed that sugarcane juice how it is prepared. You have to put that sugarcane in the machine, and then the person, it keeps on moving that handle, and then the juice is extracted. A similar way, the cloth, if you see the earlier washing machine, that you have to put that what we can say the cloth in that machine, you have to use that handle and then it will be dried. That was the mechanism, and now you see how it is now made from this way to then dryer and then now the automatic thing. Definitely that whatever the solutions are there which are made, obviously you can consider it for the grant of a patent. Okay. Now, the next is the last one is a prior art motivation. Rather, we have seen in one of the module the patent analytics or the search and analysis and how you can use a patent effectively. Every researcher, I will suggest here that every researcher, if he is working on some problem, if the problem is like a broad problem is defined, then we have already seen that they should go through the prior art, and we have given you the idea that how you can apply that patentability tool. There you can check what are the different resources that to check the prior art, right. So, if somebody goes to that prior art, that what are the different solutions are tried for that solving that particular product. So, you get the long, what we can say, the data, the long list or the data, rich data, that how this problem is considered by the researchers who are working in that area. And then by knowing all this thing, right, by understanding that background, that understanding by the literature, and obviously we have insisted use of patent analytics especially. So, if you do that analysis, definitely this is like a, that will give you the motivation. Oh, this was the issue for all last so many years, it is not solved. And here, if that particular gives that prior art motivation, that is you have seen the prior art, and from prior art you have identified the problem, and now you are working on it and you are solving that thing, definitely that will be considered for the patent. So, that is what the prior art motivation is there. So, we have seen the indicators as distance, surprising effect, long felt need, failure of others, complexity of work, commercial success, cheaper and more economical product, and simplicity of the proposed technological solution, and a prior art motivation, right. So, these are the indicators that will help us, and that understanding these indicators in detail, that might help you that how exactly the patent examination is followed, right. After going through these details, now let us check one small video. This is an interesting video about the penicillin discovery. Just we have cited that example.
Poverty, hunger, and disease. These three ancient enemies of man still stalk hand in hand across too much of the world. Of the three, disease can be said to be the most deadly. Disease often fathers hunger and poverty. This is the story of how one of the mightiest weapons against disease was forged. It is the story of penicillin, the first of the modern wonder drugs known as antibiotics. Today, the penicillins are only one group of antibiotics among many, and in laboratories throughout the world, the search goes on for more. To learn how the first of them, penicillin, was discovered and developed, one must know of the work of 3 British scientists. What they achieved has revolutionized medicine. Sir Alexander Fleming, for the initial discovery of penicillin. Dr. E.B. Chain, and Sir Howard Florey for their finding its curative power to benefit millions. Early in the 1920s, in London, Alexander Fleming, a young bacteriologist, worked in the inoculation department of St. Mary's Hospital. Familiar with antiseptics and inoculation as weapons to help the human body battle against disease germs, he began to wonder what natural defenses might be possessed by exposed parts of the body, such as the eyes. In each place, Fleming found a protective substance which could destroy some germs before they invaded the body. Some germs, but not all, and not the most deadly. In one of the glass dishes where he cultured germs for his experiments, Fleming noticed one day in 1928 that some mold, such as appears on decaying food, had begun to grow. A spoiled experiment. But with mind alerted by the earlier work on protective substances, he looked closer. He saw that near to the mold, no germs were growing. Might it be that this mold, like the human body, produced a substance capable of destroying germs? He made tests and found that even some of the most dangerous germs died near to the mold. He then grew the mold.
Okay, you can watch this video. It is a little bit longer, so you can watch this video later. Now with this, we come to the end of the session. Hope you have learned how that indicators of patentability are working. See you in the next session. Thank you.